So on page 740 and page 741, they have these boxes with the binomial theorem. So they both show the formula or the idea in different ways. The first one is saying with combinations, x plus y to the n will be n choose 0, n choose 1, n choose 2, and so on as you go. Those numbers underlined in green, those just come from Pascal's triangle. And then we notice that the powers of our first term, so here our first term is x, they start with x to the n and they go down 1 each time. And the second one, which is y, you don't have any y's in your first term, then you start with 1, then 2, then 3, and they go up 1 until you get to y to the n. Now, if you wanted to take all of these ones that are underlined in green, Pascal's triangle, and expand them with the formula, that's what they've done in the second set of questions. And then on page 741, they write a general term for x plus y to the n. So what I would like you to do is maybe underneath this on page 740, you can write on formula sheet, this is what you get. For a plus b to the n, oh, I better write it out exactly as it is on your formula sheet. I think it says term k plus 1. Someone have their formula sheet handy? Yes. On your formula sheet, it has term k plus 1 equals n choose k, a to the n minus k, b to the k. So what they're saying on the formula sheet is taking this that we have at first and compressing it into one formula. If I wanted to find, for example, this one would be term 3. What do we notice? In term 3, we have n choose 2. So this number here is 1 less than whatever the term that you're finding. On your formula sheet, if I wanted to find term 3, can you see that k would be 2? Okay? N always stands for the exponent that you have, because it's for a plus b to the n, so whatever exponent you have would go there. N choose k. A to the n minus k. So notice in this one, the third term, whatever number it is, you would have already gone down by 2. So that's why it would be n minus k. And your second term would be whatever exponent that would be. So you can use this formula to find any specific term. And usually what happens as we get to questions with bigger values, like example 2 here, well, example 2 still asks us to expand and simplify, but when we get to example 3, which we're going to do right away after example 2, we find a specific term. So here, example 2, expand and simplify. If we're using Pascal's triangle, since the exponent is 3, we know that there's going to be 4 terms. And so 4a squared plus 2b all cubed will equal, and I can go to Pascal's triangle to 4 terms, and I know that these will be my coefficients. For my first term, I will have 4a squared cubed. Then I'll have 4a squared squared, then 4a squared, one of them. My second term is 2b. I won't have any 2b's to begin with. Then I'll have 2b to the 1, then 2b squared, and finally 2b cubed. Expand and simplify, so we'll use our exponent laws first. 4 cubed is 64. A squared to the 3 is a to the 6. Plus 3 times that squared will be 16a squared times 2b. Plus 3 times 4a squared. 2b squared will be 4b squared. Plus, and 2 cubed is 8, and b cubed is b cubed. And then you can multiply, so we'll have 64a to the 6 plus 96a squared b plus 48a squared b squared plus 8b cubed. All right, you can do question number 7 for practice, but we're going to do example 3 right away.